Have you ever considered what types of data the businesses and services you use might be interested in capturing and how they store it? Well, we're going to think about that a bit as we walk through the process for completing Assignment 1. In this assignment, I ask you to identify 3 companies and think critically about how they use databases to enable their business. For each company, I ask that you identify 2 entity types they need to keep track of, 5 attributes for each entity type, and create a data dictionary that describes the attributes and the entity type or table that they are associated with. Then we're going to draw an ERD showing the relationship between these entities, including the cardinality and participation constraints. We're then going to provide between 3 and 7 instances of some sample data just to kind of make sure everything makes sense. And then write out a couple of business rules that inform the attributes and the structural constraints of cardinality and participation. Now, there are many tools you could use for this. I'm going to suggest that the bulk of this is going to just be created in Microsoft Word. And then for creating the entity relationship diagram, Microsoft PowerPoint is really a great tool for being able to easily create beautiful diagrams. That's what I use for pretty much all the diagrams we see in this class. There are more complex tools that offer a richer feature set, but for what we're doing right now, PowerPoint is really going to be a great and pretty straightforward option. So let's go ahead and get started. In this video, I'm going to be walking in depth through one example and also pointing out a few common mistakes that you're going to want to avoid. I'll then kind of briefly talk about some other possible use cases and how that would differ from the example that I'm going through in depth. But just to be clear, the point here isn't that you should exactly follow this video. You should not submit the same thing that I'm showing you here, but hopefully the thought process and the workflow that we're going to go through is going to inform your completion of the assignment and kind of help you understand exactly what you're going to be doing. So let's go ahead and get started. So I have here pulled up on the left the assignment files. So here's the description of all of the deliverables, a few notes and things to be on the lookout for. And then on the 3rd page, I have an example of exactly what I want your submission to look like. So on my submission here on the right side, I'm just going to kind of duplicate this structure. So I'm creating a numbered list first, and I'm going to say company number 1 that I'm going to be looking at. I'm going to do a grocery store, and specifically, let's say H-E-B, right? Because that's a very nice Texas-based grocery store, but this could be H-E-B, Kroger, Randall's, really any grocery store. But I'm thinking of one that has like a loyalty card program where they track customers and what they purchase and give discounts based on your loyalty points and things like that. So I'm going to say company 1 is H-E-B. The entity types that I am interested in, we're going to say customers and products, right? Now, other entity types might be things like employees and shifts, right? Because employees are scheduled to work certain shifts, right? But yeah, customers and products is what I'm looking at here. The attributes for each one of these tables. And I'm going to hit Shift Enter, which will get me to a new line without incrementing this numbered list. For my customers table, let's say we have like a loyalty program ID number, name, phone number, address, and let's say the loyalty points that they have accumulated, right? And generally the way these systems work is like for every dollar you spend, you get a point, and then you can redeem those points for discounts on fuel or for coupons or something like that. So these are the 5 attributes I'm tracking for customers. One thing I'll point out here, note that I'm not including things like weight. or height or eye color or anything like that as an attribute of the customer. Now, it is certainly true that those things are attributes of that human being that is a customer. And in some other contexts, like in a doctor's office, maybe height and weight are attributes you would want to track. But for the purpose of a grocery store, they're not really concerned about your height or weight. What they want to know is your name, your phone number so they can, send you messages or whatever, your mailing address so they can send you coupons, things like that. So make sure whatever attributes you select are things that the company would realistically have access to and be interested in. Okay, so I think this is a good set of attributes for our customer. And then again, Shift Enter to go to the next line. Products are uniquely identified by a UPC or Universal Product Code. We're going to say product name. Let's say manufacturer. Price, that's a good attribute of a product. And let's say we want to know the quantity of the product that we have in inventory, or how many items we have in the store. I think that's a great set of attributes. So we're going to move on to our data dictionary. And actually, before we do that, because you see I've got some kind of change up in my spacing here, just because of the way Word handles these numbered lists, I'm going to go ahead and populate the rest of this before I do anything else, so Word doesn't get the numbering all messed up, because Word can be a little bit finicky sometimes. So I'm going to hit Enter and go ahead and just create these headings for ERD, tables, and then number 7 is business rules. All right, let's create our data dictionary. So I'm just going to hit Enter. That kind of erroneously creates this number 5. I'm going to hit backspace once to get rid of that, and then again to kind of get my indentation back to the left a little bit, and then backspace again to get it there. And I'm going to create a table that looks like this. Looks like I have 4 columns and then 11 rows, because I have this header row and then 5 rows for each one of the attributes. So right here, I'm going to go up to Insert, Table, and I'm going to say I want a table that is 4 by, and I can't get all the way to 11, but we'll get 8 and then add some more later. And so this is attribute. I hit Tab to go to the next cell, table, data type, and length. And then just to pretty this up a little bit, I'm going to highlight all this, Control B to make it bold. And then from my Home tab, I'm going to give this a nice background color. I like this kind of light gray here. So that's just kind of setting aside this header row from everything else. And then table, we're going to start with our customers table. And I'm going to just copy this and then select these next 4 cells and paste. And then paste the same exact thing into each one of those cells. My attributes here, loyalty ID, down arrow name, down arrow phone, address, and loyalty points. All right, now we need to specify a data type for each one of these attributes. So let's I think start with our most obvious ones here. So name is going to be a text data type, and as we're going to discuss a little bit later in the semester, there are a number of different types of text or alphanumeric data types, and those can vary from DBMS to DBMS. So we're not going to be too concerned about the exact type of text data type that we're using here, but we're just going to generically either call these text as in alphanumeric, or number as in just a numeric data type. Name is going to be text, address That's alphanumeric as well, because you're like, 123 Main Street or something like that. So that's going to be text. Your loyalty points, this is going to be a number that accumulates, right? Every time you make a new purchase, if you start out with 0 loyalty points, and then in one transaction you earn 100 loyalty points, and then you add 50 more in the next transaction, this is a number that you're adding to every time. This is pretty much definitely going to be a number, some type of numeric data type, be an integer or a floating point or something like that. Now, phone number and loyalty ID. Let's look at phone number first. Now, for phone number, you might be tempted to say phone number, like obviously that is a number, right? And at the core, you would be right. You got these numbers like 281-330-8004, right? And so these are all numbers, but this isn't really formatted like a phone number. Often you see dashes in between the area code and the 3-digit prefix, and it would be something that looks more like this. Okay, well, here's where it gets a little bit tricky. You cannot include any non-numeric characters in an attribute that is of a numeric data type. Okay, so we wouldn't be able to put these dashes. We could only put the actual numbers, right? Which might be fine, but might kind of make things a little bit more confusing, right? Or if you wanted to have this in parentheses and then a space and a dash here, we couldn't do that if the data type is number, okay? But more importantly, would you ever do any type of math on someone's phone number? Like, does it make sense to divide someone's phone number by 2 or to add 100 to your phone number? No, that's nonsense. That doesn't make any sense. So generally speaking, if you're not going to be doing math on something, like you add to the loyalty points or you deduct from the loyalty points. So that's great to be a number. If you're not going to be doing math on something, it's generally going to be a little bit better to store it as text instead of a number. And one of the reasons for that we're going to find later in the semester is if we've stored a value as text, we can use string manipulation functions. So if we wanted to show only the last 4 digits of a phone number, right, and make it look, something like this, like to protect someone's privacy, this is very easy to do if we've stored this as text. Much more difficult to do if we have stored it as a number. So I am going to suggest that phone number is going to be text. And then kind of similarly, our loyalty ID, often we see that as just a string of numbers, but I definitely have some loyalty programs or membership cards that have letters as part of my membership number as well. So I'm going to suggest text is probably a pretty good data type for that as well. Now for our text attributes, the length is going to be literally the number of characters that we're going to accept for that attribute. One number that you commonly see used in computing is the number 255. And this is just because in computing in general, when you have 8 bits of memory, you have 256 possible values, 0 through 255. So you often see 255 just being used as a number in computing stuff. So it's probably a pretty good length for name in case you have someone with a really long name. Also probably a pretty good length for address. For phone number though, we could tighten this up a little bit if we wanted to, just to save some space, because in a regular phone number, we have a 3-digit area code, the 3-digit prefix, and then the 4 digits at the end. So that's 10. And then if we're storing with the dashes, we would need a length of 12 for that. So we can kind of nail that down a little bit. Now for our numeric data types, and I don't want to get too in-depth into this, but this is going to be the number of bits needed to store kind of the maximum number that we think we might have there. So 16 bits or 32 bits is going to be are going to be some very common sizes that we see. So 2 to the 16th, if we have a size of 16, the maximum number that we could store in this attribute would be 65,536. Actually 65,535 because computers start counting at 0, not at 1. So if we wanted to say the maximum loyalty points you could earn is 65,535, then 16 would be a very reasonable value for length. I don't care exactly what you put here, just as long as it's something fairly reasonable. All right, so that's our customers table. We're going to move on now to our products table. To make a few more rows here, I'm just going to come to the end and I'm going to start hitting tab. So add 3 more rows there. We're now on to the products table. Again, I'm going to copy that, select these, paste, just to be a little bit quick about it, and then type in our attribute names of UPC, prod name, manufacturer, price, and I can't type, quantity. Now again, I think product name and manufacturer, these are pretty clearly going to be text attributes. 255 seems pretty reasonable for their size. UPC, almost all the UPCs I've ever seen are just numbers, but then again, we're not going to be doing math on them, and maybe there could be a character thrown in there somewhere. I think it's just a little bit safer to call this text. 255 is probably much longer than any of these UPCs actually are. If you left 255, that's okay. Usually they're more like 12 to 15 characters in length. We could probably call this 20 just to have a little extra room. But again, that's kind of up to you. And then price and quantity, these are definitely going to be numerics. I doubt we'll have any products that are over $65,000, so 16 is probably a pretty good length, and we're actually going to create a business rule that constrains that as well. And then quantity, also I think 16 bits is probably pretty reasonable. Excellent, so now we've got our data dictionary complete and we are ready to move on to our ERD. Now again, I'm going to be doing this in PowerPoint, so I just have opened up a blank presentation here in PowerPoint. I'm going to delete this stuff that we don't really need. And I'm going to get started by going up to the Insert tab and this Shapes button. And in the drop down, I'm going to select our rectangle shape. So I'm going to make that just kind of guessing at what a reasonable size would be. I like that right there. And I don't like this blue color so much, so I'm going to go to the Shape Fill and make the fill white. And I'm going to make my shape outline black. All right, so now we have a very nice rectangle here that represents one of our entity types. And we're going to say this is for our customer entity type. So if I double click, I can start typing in here, CUS, and oh no, I don't see anything. So I need to make sure I go to my Home tab and select black as my text color. So now, there we go. Customers, and let's make this just a little bit bigger so it looks nicer. Excellent, I like that. And now we need a box to represent our products entity types. So in order to keep things very nice and consistent, instead of drawing another rectangle, I'm just going to select this and then Control C to copy and Control V to paste. Now I have a box of the exact same size. You see these little lines that pop up. I can even make sure that I'm perfectly aligned with the box that I previously created. Now this is just, really helpful for making beautiful looking diagrams. And this is one of the things that if you're going to be a really good IS professional, making things look nice is how you're going to get people to take you seriously and get them to pay you the big bucks. So I would definitely try to get into a habit of this sooner rather than later. So now we have these two boxes that are the exact same size. They're lined up. Just gonna double click here and change this to products. I'm going to go back up to my Insert tab and create the diamond for the relationship that's here in the flowchart section. So put our diamond kind of right here in the middle like this. And again, I'm going to make my fill white and my outline black. I think I need to spread these out just a little bit more. Now note that as I move this around, I get some more guidelines popping up telling me when I am equally spaced between these boxes. Just makes your diagrams look nicer, so get in the habit of that. And what's the relationship between customers and products? Well, customers purchase products, right? So we'll say purchase, and oh no, again, I can't see my text, but it really is there. It's just white. And remember, PowerPoint made this blue by default, so it had white text on a blue background. But now that my background is white, you can't see it. But if I double click right there, you see it highlights it. I'm going to change that to black and then also make it a little bit bigger. That looks pretty nice. And then finally, from my Insert tab, Shapes, I'm going to draw the line between these two things. And I'm going to make sure that I let this click to these anchor points, right? Because if I do something that looks like this, that's messy. No one wants to see that. But if I click this to an anchor point, that's nice and tight. And now if I move this, the line kind of follows along, which is what we want. We also want this line to be black, not blue. Okay, now we could just draw another line like we just did, or we could select this and copy paste again. I do a lot of copying and pasting in my diagrams so that we get a very nice, consistent look and feel here. All right, great. So this is our basic ERD, but we need to add our structural constraints around participation and cardinality. So in my head, when I think about signing up for one of these loyalty programs, I can actually sign up for a Kroger card or an HEB loyalty card before I've ever made any purchases at the store, right? I fill out the form, or I can go online and apply for one of these cards. So as I'm thinking about this use case, I think it's actually optional for a customer to have ever purchased a product in order to be considered a customer and a member of this loyalty program. So I think customer has optional participation in this relationship. Now recall that currently we are reading across the relationship to understand our cardinality and participation. So I'm going to represent this optional participation by, again, from my Insert tab in this Shapes button, getting a circle, and I'm going to draw a little circle right here, about like that. Okay, again, we're going to make the fill white, the outline black, and make sure that's kind of centered on that line. Yeah, that looks real good to me. So customer has optional participation in the relationship. Products, so let's think about this. When we start carrying a brand new product in our store, we want to have that in the inventory database before any customers have ever purchased it. So it would be very possible, and in fact kind of required, that product would have optional participation in this relationship. So again, to make sure our circle is the same size and looks the same, I'm just going to click on this, copy, paste, drag this over here, look for all my alignment lines to come up, and I see that my spacing is kind of the same in every direction, and drop that there. And now this represents that product has optional participation in this relationship, or we can have a product that has never been purchased. All right, cardinality, we're going to say insert text box and just kind of click right about here, and we'll move it as needed or if needed. So a customer purchases a minimum of 0 and a maximum of many products, right? Because just certainly we're not going to limit customers to purchasing only one thing. You can buy as much as you want. So I'm going to make this a little bit bigger here. Maybe drop that right about there. I like that. So a customer purchases a minimum of 0 and a maximum of many products. Okay. Now let's think about the cardinality of products, Should this be one or should this be many? Now it really could kind of go either way. If you think about it, once a customer has purchased a can of Campbell's tomato soup, like no other customer can purchase that exact can, right? Because that exact can is in your hand. It's in your shopping cart. It's ultimately in your pantry, right? You bought that, no one else can buy it. However, in the use case of a grocery store, they don't keep track of every individual can of soup. They keep track of this class of product of, 12-ounce can of Campbell's tomato soup, right? And we know that because when we look at our data dictionary over here, we have this attribute quantity, right? So this is suggesting to us that we have a product, 12-ounce can of Campbell's tomato soup, and we have 100 of them. And we don't care which actual can you buy. We just know that you buy a can of this soup, and then we're going to deduct 1 from the value of quantity. So this product, 12-ounce can of Campbell's tomato soup, can actually be purchased many times by many different customers. Okay, so we're going to say the cardinality of this relationship is many to many. And let's see if we can get this to line up just right. There we go. Perfect. And normally we represent this with an M and an N if it's many to many. Great. So I think our ERD is in good shape here. Now we just need to get this over into our Word document. And there are any number of ways that you could take a screenshot of this. If you just hit print screen, it will get the entire contents of your screen, and then when you take it into Word, you can crop it. I have a piece of software called GreenShot, green like the color green, and then shot like screenshot, which gives you some advanced functionality. There's also the snipping tool in Windows, and I think Mac OS has something similar, but I'm going to hit print screen, and that gives me this little crosshair here. I'm going to select just exactly what I want to bring over, and I want to come over here. I can Control V to paste that, and yeah, that looks great. I like that. Cool. So now we're going to create our tables and populate some data there. So again, I'm going to hit enter, delete a couple of times. And let's create a table that looks kind of like this. This looks like I have 1, 2, 3, 4, 5 columns, and 1, 2, 3, 4, 5, 6. Let's say we're going to have 3 tuples or 3 rows of data here. So insert my table, these 5 columns, 1 for each attribute, and then we'll say 5 rows. I'm going to select these top 5 cells here, and then from my layout tab, I'm going to select merge cells. Okay, and we're doing our customers table first. So customers, I'm going to hit Control E to center that. That looks nice. Bold. And then we'll give this a gray background to kind of set it apart from our data values. And then the attributes that go along with our customer. Loyalty ID, name, phone, address, and loyalty points. And again, let's bold all this, make all this gray to set it aside. So just so it's very clear that these are our attributes, and then we're populating some values for these attributes down here. And then we're just going to make up some things. So loyalty ID, 1, 2, 3, 4, 5, 6. This is Adam Baker, whose phone number is 555 1, 2, 3, 4, 5, 6, 7. Address 1, 2, 3 Main Street, and Adam has 120 loyalty points, right? address 55 South Drive, and they have 50 loyalty points, and then one more. All right, so we've got some sample data here. And a couple of things I'll point out. One, it's a good thing we stored phone as a text attribute, not as a number, because we would not be able to put these dashes in here if that was a numeric data type. Loyalty points, we only have a number here. We're not going to say something like 120 points, because points, these are non-numeric characters. These are alpha characters. Okay, so we can only store numbers here. As Adam Baker earns more loyalty points, when they go through the checkout process, it's going to say, okay, 120, and you just earn 50 more loyalty points. So 120 plus 50 is 170, right? So that's the beauty of doing that as a numeric data type. And then let's create some sample data for products. Kind of a shortcut here. I'm just going to click this little square at the top of this table to highlight everything. Control C to copy, and then Control V to paste. I'm going to select this and just delete what we've typed in here, but we already kind of have our framework, so maybe save some time there. Products, UPC, prod name, manufacturer, price, and quantity. Okay, PC, just gonna make something up here. Let's say Cool Ranch Doritos. Manufacturer of Doritos, I'm pretty sure is Frito-Lay. The price, actually it would probably be good to have some additional details here. Let's say this is for the 12 ounce bag, and the price for 12 ounces of Cool Ranch Doritos is, I'm not sure, maybe $3.89. Just, you don't have to be exact here, just something reasonable. Don't say this is $1 million, and don't say it's 10 cents. And the quantity we have on hand, let's say we have like 52 bags of Cool Ranch Doritos. Tomato soup. Again, let's call this a 12 ounce from Campbell. That's what, like 89 cents maybe? Not sure. And we have 20 of those in stock. And then maybe some multigrain bread from Organic Hill. And multigrain bread from Organic Hill is $5.49 for a loaf of it, and we have 12 of those in stock. Okay, yeah, it looks like some reasonable sample data. Again, with anything that is a numeric attribute, we can only have numbers or a decimal, right? So we couldn't put like a $sign here. Okay, we're going to add this $sign at the application layer, or as we'll discuss a little bit later in the semester, we can apply a character mask to add a $sign, but all we can have for a numeric value is a number or a decimal point. And then last but not least, our business rules. And these are business rules specifically that inform the design of our database. And every semester I'll have students that will provide some business rules like we only sell the highest quality of product. Okay, well, that might be kind of a tenet that your business lives by. That might be how you run your store, but that doesn't really inform anything about the database design. The business rules that I'm interested in here are things that describe how the attributes work, right? Or the cardinality and participation of our entities. So like, for example, I might want to have a business rule that is customers are required to provide their phone number, right? And what that tells me is that this attribute, phone, is required. It is a mandatory attribute, okay? That informs something about our database design. We may also want to provide some domain constraints. So we could say something like the price of a product must be between 1 cent and $1,000, right? So this does a couple of things. One, it ensures that we don't have any prices that are negative, because that totally doesn't make sense, that you would buy something and get money instead of paying money. Also, that we don't have any products that don't have a price or that are priced at zero. That wouldn't really make a lot of sense. But also, I think reasonably, there's not going to be any items at H-E-B or Kroger, a normal grocery store, that would be over $1,000. Okay, so this makes sure that we didn't intend to price a really high-end steak at like $110, but then accidentally leave out the decimal point and actually have the price set to $11,000, right? The database just wouldn't allow us to do that, because we've said the domain of price is between 0.01 and 1,000.00. Okay, so it just kind of keeps our data integrity in check. And then also, when we made the length of this numeric data type 16, recall that we said that gives us a maximum value of 65,535 that we could store there. Okay, so this also makes sure that we don't have some type of buffer overflow or data corruption or something like that. Okay, so that would be another good business rule. And then finally, if we wanted to address this kind of fuzzy thing that I talked about, yeah, we can sign up for the loyalty card before we've actually purchased anything. Let's be explicit about that in our business rules and say customers can sign up for a loyalty card without having ever made a purchase, right? So now this is very explicitly saying, yes, customer has optional participation in this relationship. And I'm going to kind of clean things up just a little bit, because I think I could probably fit all this on one page. If I do, let's see. Yes. This all looks beautiful. Fantastic. So this is roughly what your submission for a company for assignment 1 should look like. Okay, now at this point you've got 2 more to do, so just go to a new page and start over. Company name, John's Car Dealership. 2 are entity types that we're interested in. Let's call it, customers and cars. 3 are attributes, would be, whatever attributes it is that we're interested in with customers and cars. Okay. And now one thing I will point out too, and the reason I'm kind of going down this path of talking about John's car dealership, is a car dealership is a very different type of business than a grocery store, right? And when we were talking about our cardinality and participation in the grocery store, and here, let me add a little bit of detail here. So here is our ERD for the grocery store. I'm just going to copy and paste this whole thing. And we'll make this cars. So in a grocery store, we have many different instances of one particular product, and we're not tracking each product individually, right? All these cans of soup, all these bags of Doritos, they're kind of interchangeable. Now, a car, on the other hand, has a unique serial number, a vehicle identification number. And when you go to a car dealership, you purchase this one specific car, right? Every car has a different key. Your cars aren't interchangeable, right? So in this case, we do track every single car individually, okay? So a car is purchased by a minimum of 0 customers, right? Which is fair because we have some cars at the dealership that have not yet been purchased. They're available for purchase. But once a car is purchased, it is going to be purchased by a maximum of 1 person, right? So in a car dealership, a car is going to have a cardinality of 1, whereas in a grocery store, a product typically is going to have a cardinality of many. Similarly, when we think about the participation of a customer at a car dealership, you generally don't have like any kind of loyalty program or something like that. Like you may not be part of this car dealership's database until you have actually purchased a vehicle, right? So I would say it would be likely in a car dealership scenario that the participation of customer is not going to be optional, but it's going to be mandatory. So we're going to represent that not with this circle, but instead with a line. And again, I'm just going to copy and paste this, and I'm going to kind of change the orientation here, and it's not very pretty and straight. Let's get it nice and straight. There we go. Yeah, and now, so this is representing the customer has mandatory participation in this relationship. To be a customer at the car dealership, you must purchase at least 1 car, and you could purchase a whole bunch of cars. I don't think they're going to stop you from that, right? So, you have a cardinality of many. Not all cars have been purchased, but once a car is purchased, it can only be purchased by 1 customer. So this would be your ERD for a car dealership in this case, and you would have some slightly different attributes and data types and things like that. But for the next one, just kind of continue along this process, and hopefully this has been useful and enlightening and leads you to great success, not only on assignment 1, but also on exam 1, and not only on exam 1, but also in the rest of your life. You guys go forth and do great things.